Hello everyone, thank you for your time and attention today. My name is NC Kishore. I'm in the R&D portfolio team and I will be sharing some updates with you on machining and additive manufacturing. We've got a lot to cover, so let me jump right in. The 3D Experience platform has a role called as the cutting tool technologist. This role would allow you to import a P21 or an ISO 13399 format cutting tools that are readily available today on the vendor's website, such as Sandvik or Kennametal or ISCAR, for instance. They all have these formats available on their websites. You can download them and import them into the platform and simply use them. In 20X, the cutting tool technologist has a new capability that will allow you to import a large number of tools, whether they are in V5 cutting tool catalogs or it could be an external database such as TDM, Zolar, or Cuscom, and so on. You could import all those cutting tools using these macros that have been delivered in your installation today. So as you can see here, in V5, the geometrical definition of the cutting tool, and this cutting tool, depending on the type of material it's going to be used on, will have different feeds and speeds, cutting conditions, cutting parameters defined. And these were saved in different catalogs. Now this macro here would convert those catalogs into CSV files, and this is a new enhancement. This macro here, again delivered on the installation today, would convert those CSV files into an exchange file, and then that could be imported into the 3D Experience platform. So this is the route to bring in all your cutting tools, whether it's from V5 catalogs or external cutting tool databases, or even an Excel file, including all the cutting conditions into the platform. And once in the platform, you could create libraries and catalogs to manage them. So this next enhancement is in the way you create new tool assemblies. We have the similar search command embedded right within the cutting tool definition panel. So when you're creating a cutting tool or a holder or a tool assembly, you could do a similar search in the database for those components or assemblies. And if you find one, just reuse it rather than recreate it. And this way you're also avoiding the replication of the same cutting tool or components inside the database. And the similar search is also applicable for components coming from a catalog. You could do a similar search and search for components from a catalog. So the next one here is to be able to make modifications of the tool number and also the local tool gauge. In the past, to make a change on the local tool gauge, you had to edit the cutting tool and then make the change there. But here, as you can see, it's right from within the machining definition panel. You could make the change to the local tool gauge and see the effect of it right there. And this way you could avoid the back and forth between the cutting tool definition and the machining definition. And the local tool gauge could also be locked by the cutting tool definition supervisor, so to say, if need be. And there's an option to do that on the tool definition panel so that the NC programmer cannot make the changes in the tool gauge here. Okay. So the last one here is support for the library model. In the past, we used to be able to capture cutting tools inside the catalog, but in this new way, we are able to capture them in library. We can import your existing tool catalogs into the library as well. And the advantage of that is the library model is available on to access them in the dashboard or even on a web viewer to make changes if needed. This next new enhancement is around the reuse programming. It's essentially the capability to capture the manufacturing know-how and to reuse it. I have a couple of videos here that I'll replay and you'll get an idea of what I'm talking about. So here the NC programmer has a large part with a number of pockets. He's creating operations for one pocket and he's able to templatize that by using the templatize command. And once he's captured that know-how, he's simply able to do a feature recognition on the rest of the part and apply that template to all the other pockets. That's the template. And he would simply click on recognize and he'll identify all the pockets and simply applies the template. So 140 pockets have been found in a few seconds, and once he hits apply, he gets all those operations with those tool changes, and to consolidate the tool changes, he would do an auto sequence, and that will reduce the number of tool changes, and here's the result of it. So that's one of the enhancements. And the second enhancement is around the reuse programming again. And this is essentially the ability to apply more than one template to the features on this part. So here there's a template for the groove, a template for the pocket, and also a template for the stiffener. And with all these three, he could do a feature recognition, and it recognizes those features on the part, different variants of it, and he would simply apply and be done with programming. So this reduces a whole lot of time for the NC programmer during programming. So there has been numerous incremental and some significant value-added features across the heavy-duty operations such as roughing, prismatic roughing, cavity roughing, power machining, and so on. And some of them are listed here. The radial engagement rather than ramping into the pockets, automatic detection and circle interpolation around the radial corners that you see here. And the axial location is now, it's not dependent on the machining tolerance anymore. It's based on exact geometry. And some other miscellaneous enhancements, tool holder management, and of course we are now able to output helical syntax in the APT output. Okay. The next one here is the adaptive concentric milling, or ACM for short. This has been available since 2017X onwards, and it has been a huge hit. So ACM was designed for hard material machining such as titanium, Inconel 7, die steel, and so on. And ACM now has additional performance improvements that support dynamic pattern, which means that this allows constant tool radial contact for each cutting point, and this results in higher machining quality and also increased tool life. The downside of this is higher computation time, but we are working on that, and R&D is working on that to improve it, and in the coming releases you should see a significant improvement there as well. The next one here is the support for battle cutters. So we are now able to support battle shape, oval form, taper form type of cutters, as you can see here. With these types of cutters, you can reduce your machining time and increase your surface quality because of the higher axial depth you can achieve with this, and also for the higher radius that you have on the flank of this tool, you get a better quality of surfaces. Now the Z-level machining now includes a helix strategy, a guiding strategy that's included here, as you can see, and this would allow for machining of cavities like you see here, without having to do having extra macros to retract and approach and so on. It'll be a continuous toolpath. So the rework area command, or the feature capability we have today, has a sort of a permanent restriction. It is not able to detect material left on holes and grooves and so on. So to counter this issue, we have the ability to do a rework area on intermediate stock. Now, by doing this, we're able to find all the remaining material on the part, and this is supported in sweeping, panel contour, Z-level, advanced finishing. And this way, the programmer doesn't have to spend a whole bunch of time trying to fix those issues. By using the intermediate stock, he can achieve all those remaining material could be identified and machined. So there's this new tool that is introduced by the tool vendors, and we are now able to support this type of tool with automatic inverted way of machining option checked down here. So you can actually flip this and invert it and use this tool in the other direction as well. So we're able to support that type of tool. The next enhancement here is we have introduced the concentric option in groove turning operation as well. So as you can see here, okay, that should give a very good quality of machining there. Okay, and the next one here is again a new type of tool. It's a parting tool, but it's y-axis parting, so that's the difference here. And we are now able to support this type of tool as well. So there has been usability improvements across the portfolio of the machining solutions or apps or roles. So here are a few of them that's most commonly used, and this would eliminate the number of clicks. So in the past, in order to take the output of the setup 1 as an input to the setup 2, you had to do some things manually. Now with this new enhancements, you don't have to do any of those messy stuff. You just have to, it just automatically does. You don't have to do anything. It automatically takes the output of the setup 1 and puts it as an input for the setup 2. The second enhancement here is double click to activate and deactivate macros. Some of you might remember you had to right click on the approach of these macros and to activate it, few clicks there, but when you're using it a number of times a day, it goes a long way. So just double clicking on this thing would now activate or deactivate the macros. And there's also copy paste macro you can copy it from one operation to the other operation or from one process to the other as well. So these are a few of them here that's worth mentioning. There are numerous others that have been also delivered, but we'll focus on the ones that are most commonly used. So moving on to the next one here is with wire EDM. Now wire EDM is a role, well, it's not a role, it's actually a part of the prismatic programmer role. It's delivered at no cost. So there's actually a huge value here. We have an entire toolbar with all kinds of capabilities here included in the prismatic programmer role. Okay. And now here with some new enhancements, we have the automatic search of identical geometry elements. Otherwise you had to go manually pick each and every geometrical element, but now it automatically identifies that. That saves a whole bunch of time. And also, as you can see here, we can support some complex contours and shapes and run the wire to get those the programs done. So there has been a number of enhancements delivered on toolpath and machine tool simulation. Some of them are mentioned here. Optimize is one of the options that's just available in the preferences, clicking on which it will automatically set some preferences that will improve your simulation speeds. Now this has been proven compared to V5, the simulation and 3D experience is much faster and the results could be achieved much sooner. Some other good number of enhancements are around the clash detection capabilities, so the sweep-based continuous clash detection, new clash detection with probe options. Now, one thing that's really worth mentioning is the fact that the simulation is now independent of the step size, which means that irrespective of how high your step size is set to, we are able to capture every clash that occurs during simulation. And this is a key point worth noting. And some other, and also the types of faults, what kind of fault has occurred, and also the ability to go and make the change or make the fix from within the simulation environment or within the fault list. You can right click on the activity name and edit the machining operation and fix it right from within the simulation environment. Another enhancement on the choreography capabilities, where you can include some of your comments that you would like the reviewer to see when he's playing the simulation. And another final one here is enhanced measure command, which will allow you to measure between an intermediate stock. You can stop the simulation and from an intermediate stock measure between the holder or whatever situation you're in there. So when it comes to post-processing, as it was in V5, we still partner with these companies here, Senet, ICAM, and IMS. And we also have a new option, My Post Processor, which means that it will allow you to use your existing post, which you might have developed in a different programming language, let's say Fortran, for instance. We could use that and associate that to your programming environment. Now, what's worth mentioning here is that the ICAM foundation is now embedded within the code that you install, which means that you have the ability to author your own post processors for ICAM. It's also worth noting that these vendors deliver close to about 60 post processors, which is already included in your install today. And these are mostly 3-axis only or 2-axis for lathes, which is already included. You can use them for free for the first 30 days or first 90 days, I believe. And then you'll have to acquire a license for that. But you can also edit your post processors by clicking on the post processor developer and make those changes. And for anything that is 5-axis, you'll have to contact whichever vendor that you're with, and they would assist you in making those changes. And so that concludes the machining part of the updates for 20X. And now let's move on to another favorite topic of mine, additive manufacturing. So a quick run through the different techniques that are out there before we go into the updates for 20X. As you can see here, there are a total of 7 different additive manufacturing techniques, of which we support 3: the powder bed, direct energy deposition, and metal extrusion. And as the market demands, we will get into the other techniques as well. As some of the machine vendors listed here for the powder bed, so there's Renisha, Triumph, Add-Up 3D Systems, EOS, SLM, Farsoon, so on. And for the polymers, we have BAM-CI, Siaki, Mazak, Stratasys, 3D Systems, and so forth. And these vendors are except a couple of them, we are partnering with most of them here. That's listed here, not all of them yet. And in order to access their APIs, and when we generate the output from 3D Experience, they can simply take the output and print it. And that is true with some of the machine vendors such as Renisha, EOS, and Farsoon, for instance. And we are working with an Add-Up as well. And we are working with other vendors to support their machines in the platform. Now, here's a quick workflow for the powder bed programmer. We start off with selecting a part. And this part could be coming in from multi-CAD. It could be a multi-CAD geometry. And so we bring it into the platform and we set up the resource, the material, the definition, machine, build tray, and we position the parts, do some nesting here, and then we generate support structures. And then we slice the part, and then we generate the scan path or the laser paths for the specific powder bed 3D printer, and then we generate the output. Okay. Now, before we get into some details, here's one of the things that is a key differentiator between us and what's out there in the market. So this is a new role, distortion checker. This is actually a Simulia distortion checker that is available through DELMIA for powder bed users. What this role would enable you to do is it will allow you to simulate the buildup, analyze for the part displacement and part distortions and so on before you generate the output. So here's the workflow for that. So you see the process defined for a given machine powder bed. This process definition is coming from DELMIA powder bed programmer. And then we mesh the part, support, build tray, the entire setup. And then we apply an eigenstrain library. And what this eigenstrain library is a predefined set of rules coming from the simulation analyst that is bundled into a sort of a black box. So the engineer here developing this process would simply consume this eigenstrain library and generate the simulation pattern based on the scan path that's coming from DELMIA, and then he would simulate the buildup. when he simulates the build-up, he will be able to analyze the distortion, displacement, and the spring back behaviors and so on. And the idea of this thing is that the engineer can go back to his process definition if he wants to make a change, and then see that particular displacement or distortion reduced as he develops this process for printing the part. And that's the value of the distortion checker. And this is all integrated, and it's just a part of his workflow when he's defining the additive process. Okay. So part preparation for additive manufacturing is a new role that has been added. And what this would allow the additive engineer to do is simply prepare the part for additive manufacturing. He would receive the design part. He might want to actually cap the holes, as you can see here. He might want to raise the boss because it's going to get machined eventually. He might want to add a label or a logo or a part number on the part. He might want to scale it. And all this is part of preparing the engineering part for printing and before sending it to the powder bed fabrication process. That's what he's able to do here. And this is a very key step before you start preparing to scan the part or slice the part and so on. Some of these capabilities are coming in from 19X, so it's worth mentioning. So part layout improvements, there have been numerous small enhancements that help you save time during setup. So capability to analyze the current status as in collision between the part and part, or part and build tray, or part and envelope. That's very easily seen. And the 2D nesting is you have a choice between the real contour of the part or a bounding box. Based on that, it'll automatically nest it for you and position the parts. And the supports are kept when moved with the part when changing the part position. So if you decide to remove some parts or relocate some parts in the build tray, the supports don't have to be regenerated. It moves along with the part. So there are some time savings as you define the process. Some support definition capabilities here. Support for multi-edition. So you can select multiple support structures and edit them at the same time. You don't have to do it individually as before. And you can look at previews of the support structures before they are generated. So there again, you save time before you make a decision. And you can create your custom zones by just drawing on, like scribing right on the part, and the zone will be identified and you can create a support structure. So there's more flexibility in how you generate and where you generate the support structures on the part. So here are some usability improvements that have been delivered. First one being the wizard. This is what it looks like. The wizard it's basically a sequential flow of activities that you have to go through to define the additive process. And this is how it appears on your 3D experience window. It's an undockable window here, and these green check marks normally when you start off it is red, and as you satisfy the criteria it changes color to green. So you know where exactly you're in the process. You can scale the support structures. That's the new enhancement. There's also a new command to generate an output, which is the setup. Like with the build tray, the support structures, and the part, which is used for post-processing, for machining, or even for wide EDM situations. So this entire setup could be generated with one click of a button. And this could also be used for process planning scenarios. So the DELMIA process planning set of roles we have could also use the output from here. Here are some additional enhancements that were delivered for generating support structure, more flexibility, creating a Z offset between support and the part. You can actually use a CAD geometry to define that as a support structure. Differentiate the various types of support structures. So essentially, if you have or a wired support structure, you can define a specific scan path strategy which could be applied specifically to those support structures. So whenever you define that, it automatically by default applies that strategy. When you generate an output, you can actually choose what kind of elements you want to output. So there's part, if you have used the part, a CAD geometry as a support structure, or whether you want to generate a tree and a conical support or wire support, you can just check them on or off to generate the output. Now with 20X, we have introduced 3D nesting. This new capability would allow you to automatically position the parts based on its contour or the volume, either in 2D or now in 3D as well. So if I play the video here, so you have some default rules that you can apply, or you can define the number of parts you want to. So those are some options, the nesting options, and based on that you can position multiple types of parts, as you can see here in this example, and it will automatically position the parts based on your criteria that you define in these rules and in the layout rules, of course. There is also a pattern based positioning, as you can see here. You can copy the support structures and the parts, and it's simply a drag. Just like that, and if you update, you can generate the support structures as well. So here's another key enhancement in best orientation. So positioning the part on the build tray for maximum heat dissipation and for better quality of the print, it's very key to have these different controls on the criteria, and that's what we deliver here. As you can see here, we have the different criteria for positioning, and doing a fast orientation. There's also this manual orientation. With the fast orientation, you get the different results, as you can see here, based on your criteria. And you can go and, as you can see here, select which you want. You can interact with them. You can see, you can have a preview of where the support structures are going to be generated in that orientation. And with that, you can make a choice of what's the best orientation. And you could apply to one part, or if you have 10 parts, you could actually apply it to all of them. And that way, you have the best control on the best orientation that you want to have the parts on the build tray. This next new enhancement is very key for mass production. It's all about labeling and tracing. We are now able to create labels on a part or on a set of parts nested on the build tray, either in 2D or in 3D, and in an incremental fashion. Or if you have a predefined CSV file with a predefined set of labels that you want to use, you can import them and use them here. And once you create the labels on the surface, the labels would take the profile of the surface. If it's a curved surface, it takes the shape of the curve. And if there's a design change on the surface, the labels would get updated and they stay associated. There are a number of other enhancements, as in you can make this sit on top of the surface, or you can actually make it hollow, or it could be through the part. The label could be through the part, so when it gets printed, the label you can see through it. It's a hollow looped part. That's what we call it as. And as you can see here, I'm going to skip the video a little bit so you can have a number of parts, and you can also have more than one type of part. So the labeling rules could be applied to one set of part. This is what I was mentioning about through. You can see through, and see here you have more than one type of part, and if you're applying a different set of labels for this part here. So again, a lot of flexibility in defining labels and tracing the different parts that gets built on one single build tray. So that's it for the powder bed programmer enhancements, and next we're going to be talking about the material deposition programmer. This is for all polymers. This is the workflow. We get the part, we prepare the part for printing, very similar to the Power Bed programmer. Select the part and resources, mount the part on the resource. We generate and simulate the extruder path. This is machine simulation. Then we are also able to simulate for distortions with the distortion checker. And then we are able to generate the G code, the traditional G code for that machine. So that's the flow, and here's an example of what it looks like. We select the part, we define the rules and strategies, tolerances, and then we're able to do a simulation. Here's the extruder path simulation. We're also able to simulate the material deposition. You can go and measure it, and this has been proven on a real machine, as you can see here. That's the part. So it's driven by G code, it works, and we are also able to support robots printing the parts. So this robot could be driven off of G codes, or it could be a robot language. Doesn't matter. We are able to support either one. And the next highlight here is we are able to support the hybrid manufacturing, combination of additive and subtractive. As you can see here in this video, we have, or in this process, we have a combination of the material deposition, which is where you see the simulation of the extruder laying the material and the material buildup. And in the same process, we're able to change cutting tools and go and do a post-processing or machining of this part. And this would support some of those hybrid machines out there, such as the Morisi Key or the Mazak or the Thermwood and so on. So that is a quick run through all the highlights of machining and additive manufacturing. I would highly encourage everybody to be a part of the DELMIA fabrication community. You can just Google it and join the DELMIA user communities. And we use the community to post new enhancements, new features, tips and tricks, methodologies, how-tos, and so on. It's very active, and we also have machines that you can download from there and use it in your scenarios. So that's it from my side. Again, my name is NC Kishore, and thank you for your attention and your time.